Now what we have here is something called a Chladni plate, and this is based on a device that Chladni developed in the 1700s to investigate how sound moves through solid objects like these. So you've probably seen waves on a string or a slinky where you've got them oscillating up and down like that. That's essentially an object with one dimension oscillating the second dimension. Here we've got a two-dimensional object oscillating the third dimension, so we get much more complicated patterns. And what we have here is it oscillating at the fundamental. So we have a maximum of oscillation produced there, the antinode, if you want the technical physics term for it. Where I bow it, I'm essentially plucking it multiple times a second, and that produces an antinode there with lots of oscillation and a node in the middle where there's very little oscillation or no oscillation at all at one point. And what that means is the sand that's at our antinodes, where there's the maximum wobble, will be knocked into the patches where there's no wobble at all at our nodes. And so the pattern here that we see is the pattern of nodes that allows us to infer what shape the waves are through this object. And that allowed us to investigate acoustics in a way we hadn't before. Chladni was called by some the father of acoustics for developing this. And to give you an example, what I can do is I can bow it halfway along, where hopefully now in that case, we're doing the first overtone. Well, this is about an octave higher actually. So instead of one wave across the whole thing, we've got two waves. So we've got an antinode here with lots of oscillation, a node here with a little bit of oscillation and none at all, and then another one, and then finally a node right at the corner here. So that shows that rather than one big wave, we've got two smaller waves. And finally, if I do this little bit here, then we get the second overtone. In this case, we've got our antinode here, a node here, another antinode, and that. So we've got four waves rather than the two that we had before. And so this shows us the oscillation that's taking place on this plate, allows us to understand the acoustic properties of it, and was quite groundbreaking back in the 1700s when Chladni did it then. Nowadays, of course, we do everything digitally and with fancy bits of electronic technology. There's something rather nice about an oscillating bit of brass plate.